Assalamu alaikum. Bismillahirrahmanirrahim. My name is Muhammad Fayaz and I have done Master of Philosophy in Physics from University of Peshawar and currently working as a physics lecturer in Leeds College, Peshawar. Today my topic is linear momentum. The outline of this topic is introduction, explanations, formula, units, quantity, key features are factor affecting on momentum. The momentums are linear momentum means one dimensional, momentum means mass in motion. The definition of linear momentum, the product of mass and velocity is called momentum or linear momentum, and it is denoted by P, and P can be written as a formula. P is equal to m times v. M is the mass of the object and v is the velocity of the object. So simply we can say that momentum represents the motion of an object. When a body in a state of motion, it has a momentum. For example, a body of mass m and it is placed in a point A. When we applied some amount of force on this object, the object is displaced from point A to point B. So it covers some distance, and during this distance it has a velocity. So velocity is associated with this mass. So therefore the momentum of this object is denoted by P. And we also derive the unit from this equation. So P is written as it, and mass unit can be expressed in kilogram, velocity is expressed in meter per second. So the SI unit of the momentum is a kilogram meter per second. But we also interested to the other unit for the explanation. So in case in the CGS system, CGS means Gaussian system. In the Gaussian systems, the mass can be expressed in gram and distance can be expressed in centimeter per second. So the CGS unit of the momentum, gram centimeter per second. In British engineering system or FPS system, the mass can be expressed in pound, distance can be measured in foot, and time unit is second. So pound foot per second is the unit of momentum in the FPS systems. Momentum is a vector quantity because it follows the direction of velocity. So the velocity direction is also exact as the direction of velocity. So it is a vector quantity and it depends upon the direction and as well as magnitude, because vector quantities are those quantities which has magnitude and as well as directions. The other key features we can explain momentum. So first one is the proportionality. If the mass or velocity of the object increases, its momentum also increases. There are two cases. The first case, P is directly case of the object is remain constant. For example, we have two bicycles. The one is the velocity is 20 meters per second and the other velocity is 40 per second, but the both bicycle having the same mass, m1 become equal to m2 and that mass is 100 kg. The momentum of the first mass m1 p1 is equal to m1 v1, and m1 v1, when we put the values we get the answer, and this values is a 200 kg meter per second of the momentum of the first bicycle. The second bicycle having the mass is same but the velocity is different, the momentum to become 4000 kg meter per second. So therefore we can conclude that the momentum of the velocity v2 40 meter per second greater than the momentum of the first one whose velocity is 20 meter per second. But when we from this equation we conclude that the velocity of the first one is less. Why? Because the momentum is less. The velocity of the second one is greater. And similarly in the second case, momentum is also directly m, but in this case v is remain constant. For example, two car, the one is 1000 kg, and let's suppose we take a bike whose mass is 500 kg. So which one has the greatest momentum? If the mass of the bike and the mass of motor car, so motor car having greater mass, so it has greater momentum as compared to the momentum of bike. The other points is the direction, and the direction of momentum is same as the direction of velocity I discussed in the earlier. So therefore we also explain the momentum in our daily life. So a daily life example of the momentum in the transportation safety. Consider a passenger sitting in a car and accidentally the car is collide with another car. So accident is occur. During the accident, the seat belt or airbags reduce the force experiences by the passenger. Therefore, the momentum of the objects or a person sitting in a car and the car momentum, both are the change. So during this change, the momentum is remain conserved. So in the real life examples, momentum also play a vital role in the transportation safety. The other example in the space explorations. Consider a rocket is moved upward in direction. So rocket spilling a high amount of fuel or gases from the bottom. This is the action, and the reaction force applied on the rocket in the upward direction. So during the reactions and actions, the momentum of the rocket remain conserved. Therefore, the rocket move upwards. And in the collision case, the momentum also play a vital and very important role. In daily life, we have seen many things which are collide. Consider the collision of billiards ball. So the billiards ball, let's suppose this is the first one and this is the second ball, the M1 ball and M2 ball. These are the mass. This ball is collide with the velocity v. So the balls change velocity. The velocity of this one, let's suppose 5 meter per second. The velocity of this one is 0. But after the collision, M1 to become in rest, while M2 is moved with the velocity v1 5 meter per second, v2. So this is the velocity transformation. The momentum conservation also existing in the collisions. Thank you.